Let's look at how we might model division for integers. So we're going to use a chip model for integer division. And I'm going to show you how we do that with some examples here. So negative 15 divided by 3, we're going to think of as partitioning 15 red chips, right? So negative numbers are represented with red chips, into 3 groups and determining how many chips are in each group. So I'm going to start with 15 red chips in here. And I'm going to partition into 3 groups. This is much like the model that we saw with whole numbers. And then I'm going to count how many red chips went into each group. Each group has 5 red chips. So negative 15 divided by 3 is negative 5. Now what if I'm dividing a negative number by a negative number? So negative 10 divided by 5, I'm going to interpret that as removing 10 red chips in groups of size negative 5 and determining how many groups are removed. So you should think here it's like repeated subtraction, right? I'm taking out groups of size 5, negative 5. So I've got my negative 10 represented in my circle, and I'm going to take out groups of 5 red chips. Here's my first group, and then I've got a second group. So since I took out 2 groups of negative 5, negative 10 divided by negative 5 must be 2. We could also use the definition of integer division. So the definition here is the same definition that we saw for whole numbers. If a and b are any integers, then a divided by b is the unique integer c, if it exists, such that a equals b times c. So it's the unique solution to this multiplication problem. The quotient of 2 negative integers, if it exists, is a positive integer. So if I divide a negative integer by a negative integer, I should get a positive answer. The quotient of a positive and a negative integer, if it exists, is going to be a negative integer. So let's use the definition to evaluate the following. So 12 divided by negative 4 equals c if c is the unique integer, such that negative 4 times c equals 12. Well, can I think of an integer that I can multiply by negative 4 to get 12? Sure. Since negative 4 times negative 3 equals 12, we get to conclude that 12 divided by negative 4 is negative 3. What about negative 12 divided by 4? If I call that c, that is true if c is the unique integer such that negative 12 equals 4 times c. What do I need to multiply 4 by to get negative 12? Well, negative 3, right? So 12 divided by, negative 12 divided by 4 equals negative 3. How about part C? Again, I'm going to call this C, and this is if C is the unique integer such that negative 12 equals negative 4 times c. What do I need to multiply negative 4 by to get negative 12? 3. So that means that negative 12 divided by negative 4 is 3. And finally, negative 12 divided by 5 equals c if c is the unique integer. C is the unique integer such that negative 12 equals 5 times c. But there is no integer that I can multiply by 5 to get negative 12. But there is no integer value for c that satisfies this equation. So, I'm out of room. I'm going to write up here. Negative 12 divided by divided by 5 is undefined in the integers. Z for integers.